Hello, my name is Noah Abji, and today we're going to learn how to write expanded powers of 10 form beyond the thousandths place. So let's jump right in. So firstly, just to review, what is expanded form? So expanded form for a number, or it's a way of writing a number, where the digits are broken down into their place values. So an example of expanded form is below. If I were to write the number 2153 in expanded form, it would be 2 times 1000 plus 1 times 100 plus 5 times 10 plus 3 times 1. The reason why is because this expanded form is breaking this number, 2153, into its place values, which are the ones place, the tens place, the hundreds place, and the thousands place. This 2 here represents 2 1000s, so we write it as 2 times 1000. This 1 represents 1 100, so we write it as 1 times 100. The 5 represents 5 tens, so we write it as 5 times 10. And the 3 represents 3 ones, so we write it as 3 times 1. And if you were to do this expression out, you would actually get 2153 after multiplying and adding. Now we can also use expanded form with decimals. We use the same type of idea, except we're just beyond the decimal place now. So 38.21 written in expanded form would be written like this: 3 times 10 plus 8 times 1 plus 2 times 0.1 plus 1 times 0.01. So we're taking the tenths place and doing 2 times 1/10, which is 0.1, and the hundredths place and doing 1 times 1 100th, which is 0.01. And we can use this idea to use powers of 10 for expanded form as well. So let's take a look at that. So to use powers of 10 in expanded form, we first need to understand exactly what powers of 10 represent. So powers of 10 is when we have 10 times itself a certain amount of time, or 10 to the power of some number. So 10 to the power of 1 is just 10. 10 to the power of 2 means 10 multiplied by itself, which is 100. 10 to the power of 3 means 10 multiplied by itself 3 times total, 10 times 10 times 10, and that's 1000. And 10 to the power of 4 is 10 times itself 4 times total, which is 10,000. Now, the reason this is helpful for writing expanded powers of 10 form is because, remember, before we were multiplying by 10 or 100 or 1000 for the tens or hundreds or thousands place. So instead of multiplying by those numbers, we can multiply them by 10 to the power of something, or 10 to the power of 1, 2, 3, 4, and so on. So let's look at an example. If we were to write 302 in expanded powers of 10 form, we would start with looking at the hundreds place, which is where our 3 is, and say we would write 3 times 100. But 100 as a power of 10 means 10 times itself once, which is 10 to the power of 2. So we write 3 times 10 to the power of 2, then plus. There's nothing in the tens place, so we can skip that one. And then in the ones place, we have the number 2. So we would write 2 times 10 to the power of 0. Now, if you look at the list of powers of 10 that I have here, it doesn't go down to 1. But if you think about it logically, starting at 10,000, which is 10 to the power of 4, then going to 1,000, which is 10 to the power of 3, then 100, which is 10 to the power of 2. For every 0 that we take off, we also subtract 1 from the exponent. If we take another 0 off, then we get 10 to the power of 1, which is 10. So therefore, logically, if we take another 0 off, we should subtract 1 from our exponent and get 10 to the power of 0 is 1, which is exactly what it is. So 2 times 10 to the power of 0. And this would be expanded form for 302. So how do we use it with decimals? Well, we can use the same idea that we just used, logically figuring out what those exponents are to write expanded powers of 10 form with the decimals. So let's start again with the biggest place value, which is our tens place here. So for the tens place, we have 7 tens, so we can write 7 times 10 to the power of 1, because 10 is equal to 10 to the power of 1. Then we know 1 is 10 to the power of 0, so we can write plus, since we have 4 ones, 4 times 10 to the power of 0. Now, if we keep thinking about it logically, we keep subtracting 1 from our exponent. We go 10 to the power of 4, 3, 2, 1, 0. So logically, the next place value should be 10 to the power of negative 1. And that's actually exactly what it is. We have 1, 1 in the tenths place, so we're going to write 1 times 10 to the power of negative 1 here. And 10 to the power of negative 1 is actually equal to 1/10. And then for the hundredths place, then it should be 10 to the power of negative 2. So we can just write this out, times plus 9 times 10 to the power of negative 2. And then plus 8, which is in our thousandths place, times 10 to the power of negative 3. Then plus 2, which is our 10,000ths place, times 10 to the power of negative 4. And finally, plus 3 times 10 to the power of negative 5. And that's in our 100,000ths place. Now, if you're wondering why this works, it's because instead of multiplying like we do when we have a positive exponent, we divide. So 10 to the power of 0 means 10 divided by 10. 10 to the power of negative 1 means 1 divided by 10. 10 to the power of negative 2 means 1 divided by 10 times 10, or 1 divided by 10 to the power of 2. So it's 10 to the power of negative 2. 10 to the power of negative 3 just means 1 divided by 10 to the power of 3. And if we think about this logically again, 10 to the power of 3 is 1,000. So 10 to the power of negative 3 would be 1/1000th. And if we check our math here, this is in the thousandths place, which is why we use 10 to the power of a negative exponent to represent our decimals. All right, so now let's move on to a review question. So the practice question is, what is 982.381749 in expanded powers of 10 form? I'll give you a few seconds to pause the video. I know it's a long question, and then I'll explain the answer. So the correct answer to the question is listed below. I'm not going to read out the entire thing because that'd take a long time, but instead we'll dive right into the question. So we start always with our biggest place value, which is the 100ths place. So we start with 9, since we have 9 100ths, times 10 to the power of 2, because 10 times 10, which is 10 to the power of 2, is 100. So 9 times 10 to the power of 2 plus, and since we're not skipping any place values with zeros here, we can just keep subtracting 1 from our exponent to represent those place values. So plus 8 times 10 to the power of 1, since we have 8 tens, plus 2 times 10 to the power of 0, because remember, 10 to the power of 0 is equal to 1, and we have 2 ones. Then as we move past the decimal point, we're going to have our negative exponents. So plus 3 times 10 to the power of negative 1. And remember, that represents 1 divided by 10, which is 1/10. And 3 is in our tenths place. Then if we keep going, we have plus 8 times 10 to the power of negative 2, plus 1 times 10 to the power of negative 3, because we have 1 in the 1,000ths place, plus 7 times 10 to the power of negative 4, and we just keep subtracting the exponent. We keep subtracting 1 from our exponent to keep moving down place values. So now we have 4 10,000ths, so we do plus, 4 100,000, so plus 4 times 10 to the power of negative 5, and finally plus 9 times 10 to the power of negative 6. One thing you want to be careful about here is, for example, if this 4 were a 0, it would mean that we have 0 times 10 to the power of negative 5. Now, we don't have to include that in this expanded powers of 10 form. However, if you're just subtracting 1 from this exponent, you want to make sure that you recognize that you have nothing times 10 to the power of negative 5, and you know to skip 2 all the way to 10 to the power of negative 6 for the next thing that you're going to write. So make sure that you always subtract 1, or if you don't have to write anything for that place value, then subtract more if needed. But decimals can be expressed as 10 to the power of a negative exponent. That's all, and thank you for watching.